with that said, let's hop into the opening talk of the Paradigm Conference 2022. My talk is entitled Popular versus Less Well-Known Programming Languages. And the less well-known here, I sort of thought about for a few minutes, what's the best word to refer to a collection of languages that include APL Closure, Haskell, OCaml, and Wolfram. I know that the URL of this conference is ESOLang, which is short for esoteric languages. And there's a bunch of Wikipedia pages and websites that talk about ESOLangs, but those refer to languages that, are like white space, where the entire language consists of just white space. There's no ASCII characters other than space. There's another one called PIAT, P-I-A-T, which is just a pixelated image that defines how you run a program. So those are true esoteric languages, whereas languages like APL and Haskell, you might say are not popular languages, but you also wouldn't say that they're unpopular languages. There are a ton of folks that are using APL and Haskell and Closure and OCaml and Wolfram, but they're just, I think, less well-known than mainstream languages. So I ended up going with less well-known because I think it describes sort of best the set of languages that APL Closure, Haskell, OCaml, and Wolfram live in. And what we're going to do today is compare a very, very simple programming idiom in sort of these 5 languages versus 5 other, what I would consider more popular languages: Rust, Python, C++, Java, and Kotlin. But before we do that, let us give a brief introduction, if I can get this to work. This is going to cover a bunch of stuff that Rohan just said, so I'll go very quickly through this. I entered industry in 2014, so I was in university from 2008 to 2014 and high school from 2003 to 2008. So depending on if you're in high school or if you're just starting university, that's how it sort of lines up with my history. Just going to take a sip of tea here. I actually started my first 4 years in industry not as a software developer. I was writing code, but I was primarily an actuary, which does statistics for insurance companies. And then at a certain point, I started studying leak code problems and switched to a technology first company, Amazon. And for the last 3 years, I've been working at NVIDIA. For that period of time, I've been a professional C++ developer primarily. I've picked up other languages along the way, Python, Java, Go, specifically at Amazon. And also I've been doing a little bit of Python at NVIDIA, but primarily I get paid to write C++ professionally. At Amazon, there was a functional programming study group where I started to learn Haskell. And that was sort of my, beginning of my journey into different languages. It wasn't until really the mid 2018, at which point I had been programming on and off for 10 years since university, that I really sort of realized that there was a different way to solve problems. I had up until that point just been doing things in C++, Java, and Python. And then in the last 3 years, I discovered a programming language called APL, which led me to this whole world of array languages. And that's been amazingly fun. And I'll get to talk about that a little bit later. As mentioned by Rohan, I also have a YouTube channel, which I'll show a couple videos from in a sec. And you can follow me on Twitter at Code Report. Most of my online presence goes under the handle Code Report. And on top of that, I also have a programming languages virtual meetup where we work our way through textbooks. So we've gone through 3 textbooks, some of which you may have heard of. One of them is called Structure and Interpretations of Computer Programs. Another one is 7 Languages in 7 Weeks. And last but not least, I have 2 podcasts. So the one that Rohan mentioned was Arraycast, and the other one is a podcast with me and a good friend of mine that also works at NVIDIA. And we talk about everything from programming languages to what we had for breakfast. It's sort of a more casual and because we're good friends. And the one we just released today was all about the K programming language, which is also a derivative language of APL. So as Rohan mentioned, I didn't actually know that part of the reason this conference got started was because of my YouTube channel, but I had gotten a good sense when Rohan reached out that it was due to the fact that the kind of videos that I released are the ones that he mentioned, where I'm taking a single problem and comparing, upwards. If you look in the top right-hand corner, there's a video called One Problem, 16 Programming Languages. I'm not always comparing 16 programming languages. Sometimes it's just 2, but my YouTube channel started out in just C++, and then commenters would always ask for Java and Python. So I added those 2 languages. And at that point, I started just to add a 4th language and a 5th language until I realized that there was a ton of languages that were way more fun to program in than C++. So we're going to be comparing these 10 languages, and they are or can be categorized into popular and less well-known. So what makes a language popular? the metrics that I'm sort of using are based on these things. So I'm sure some of you have heard of these. There are a ton of programming language rankings out there. These ones listed, you can follow the links to them. One of them is called TIOB. That one gets a lot of criticism. There's another one called Pipel, Stack Overflow, RedMonk, IEEE, Octoverse, which comes out of the Octoverse conference and GitHub. And there's also a couple other sort of rankings based on GitHub statistics. But the one that I want to look at more closely is one called Language, which is actually created by another YouTube individual who has a channel called Context Free, which if you enjoy this video / my videos, you should also go check out his. So very quickly, I'm going to attempt to switch, and hopefully folks can see this. Now I need to move the videos so I can play around with this. So this is a really cool interactive website where basically you can right now have trimmed to the ones that are selected. Note that Wolfram doesn't show up on this, and that's just because this is based on GitHub. So it looks for how much code exists on GitHub, and you can play around. This is the average of all the things that they measure. But you can see that sort of the 5 that I'm considering popular, Python, Java, C++, Rust, and Kotlin, the top 3 are really the most popular ones. And then Rust and Kotlin, I'm not going to really talk about until the end of the talk. But if we get rid of these, you can see that Rust and Kotlin have really surged in popularity basically over the last decade, which is when they were sort of created. And if we get rid of these, you can see sort of the 4 other languages that we're going to look at minus Wolfram Alpha or Wolfram Language. And APL here is at the very bottom, so kind of the least well known. You can see is ranked at 254. But yeah, this is just a super cool website. I can untrim this so that you can see the full top 10 if you're curious. JavaScript and TypeScript are number 2 and 3. 6 is Go, 7 C#, 8 HTML, 9 PHP, and 10 is C. And so all of these different websites, they look at different things: Google searches, GitHub metrics, things like that. So number of job postings found on certain websites. But yeah, if you are entering this sort of conference, you might be interested in these sites. So just putting it out there, and sort of this is what I use to choose the popular languages. And then obviously you can see when we trim this that Haskell of the less well-known languages is sort of the top one, and APL is at the bottom. So let me see if I can switch back to my slide deck here. And I had this backup just in case that didn't work. But yeah, so we've got our top 5 languages, the top 3 of which are in the top 5, and the top 5 of which are in the top 14, and then the other 4 languages. So last thing I want to note before we hop into sort of comparing our languages is that this is my bias. So these are my top 5 favorite languages. Number 1 is BQN, which is sort of the most modern APL language. Number 2 is APL, 3 Haskell, 4 Clojure. And some people joke that know me well that I always put C++ at number 5 because that's what I get paid to program in. But I feel bad not putting it there, seeing as I write so much of it. And I do really love C++ as a language. It's not as beautiful as some of the other languages we're going to look at, but it still is a very, very powerful language. All right. So what are we going to solve today? The problem that we're going to look at is something extremely simple: filtering odd numbers, AKA keeping the odd numbers, because there's always a question of, what does filtering mean? Are you filtering in or are you filtering out? So for example, if you have the numbers 1, 2, 3, 4, 5, and you filter the odd numbers, you're going to end up with 1, 3, 5. So hopefully this is super straightforward. And that's the key. I thought about giving a talk where I talked about a paper called Programming Paradigms for Dummies, which talks about like 40 plus different programming paradigms and the difference between static and dynamic typing and a bunch of other things that you can sort of measure a programming language by. But then when I thought about when I was at the tail end of high school / beginning of university, what's the kind of talk that I would have wanted to see? And it's the kind of talk that would show you the code that I was writing at the time, and that the code 10 years later that I learned how to write. And so this is the first solution in Python. This is basically, and so that I didn't really start writing software or programs until my first year of university. I went to a small high school, and I don't even think they had a computer science class at the time. And technically, I did a tiny bit of programming on my TI-83. I'm not sure if graphing calculators are still a thing in 2022, but there's a language called TI Basic, and you can program little quadratic formulas. technically that counts as programming, but the first programming that I really did was in first year university in a course where they were teaching Python. And this is the kind of code that I would write. So here you're taking a list and you're going to first initialize another list, which is going to be the thing that you return. And then you're going to loop for every element in that list. You're going to check, is it divisible when you divide it by 2? Are you given a remainder 1, which will implicitly convert to a Boolean? And if so, append that element to your list and then return it. And all of the languages, all of the solutions in the popular languages, C++ and Java, are going to look basically identical to this. The spelling is just different depending on what data structure you're using. So in C++, it's going to be a bit more verbose because you've got static typing. So we're using a std vector of integers. You actually don't have to be explicit about that anymore. You can use auto in the parameter list, but for C++ 11 and not the modern versions, this is what you would write. You once again initialize an empty vector and call it res. And then we have a range-based for loop similar to our for loop in Python, where you loop through each of the numbers in your list, check if that number is divisible, or when you modulus it, you get back 1, which implicitly converts to a Boolean, and then push that back into our result vector. And then last but not least, we're looking at Java, which I always have such a hard time because I don't program in Java anymore. And I think it took me like 15 minutes to write this solution, which is very sad considering I've been a software developer professionally for a few years now. But yeah, the static typing in Java sometimes trips you up. Note that we're returning lists here, but in order to sort of initialize this, we need an array list. Anyways, I won't walk you through this. It's basically identical to the solutions we just saw in Python and C++, where you're checking if each element one by one. Note here, though, that the one difference is that when we're doing modulus 2, we have to check with equality to 1. And that's because Java is a more strongly typed language than C++ and Python. They don't allow implicit conversions of numbers to Booleans. So whenever you are using an if statement to check something, you actually have to have a Boolean there, which is sort of just a small note, which I think is interesting. And where we were calling append and pushback, here we're calling .add. So we've looked at Python, C++, and Java, and now we're going to go to our first of the less well-known languages. And as I said, I started picking up Haskell in 2018 when I was working for Amazon. And we were working through a Haskell book. And when I saw the solution compared to what the C++ code that I just showed you is basically what I would have written back when I started writing software and programming. This is the Haskell solution. And this blew my mind. For those of you that know Haskell right now, this probably isn't that impressive. But based on how much code we just saw in the Python, C++, and Java solutions, like I couldn't believe that this actually was how you programmed in Haskell. And not only this, this is actually more verbose than it needs to be. Whenever you have an argument, so the way this is saying is your function name is filter odds, and you have a single argument. In Haskell, it's pretty idiomatic to call a list of numbers x's and a single number x. And so this is your argument. Whenever your argument is just the last thing in your expression that you're setting equal to your function, you can get rid of it. You don't even need to mention it. So you, at this point, you don't need a function for this. You don't need to set up a function called filter odds because it literally spells out basically the function name in the code, which I just think is pretty phenomenal. Just so that we can compare these things and be consistent across languages. This is an alternate version where we don't use the built-in odd function. So this is a lambda, otherwise known as an anonymous function. It's just a function that doesn't have explicitly a name. So there's different syntax for this in all of the programming languages we're going to look at. It's saying here that we have a function that takes a single argument e, and then this is the body of the function. So it's modulusing e with 2. And then once again, we have a strongly typed language that doesn't allow conversions from integers to Boolean, so we have to check that it's equal to 1. So if we go back to our old solution, I want to show one other solution, and that is the list comprehension solution. So if you're a Python developer familiar with Python, you probably know about list comprehensions in Python. And they actually came from, well, you could say they come from a bunch of languages, but Haskell is one of those functional languages that has them. So here it's saying that for each element in our list of elements x's, filter them for the odd ones, and then create a new list sort of with this pipe on the left. So if you wanted, I could multiply 2 times x here in order to get sort of twice of all of the odd numbers. So it's just interesting to note that there's sort of 3 different ways to solve this. One was the just filter odd. The second one was with an explicit lambda. And then this one is with list comprehensions. Note that I have not typed a sort of function signature, or what they call a type signature in Haskell, for any of these functions. So in the C++, Java, and Python solutions, you had to start off with sort of the name of the function, the number of arguments it took, and then braces, or in Python, you use white space. So there's a question. Can you again show the previous one? This one here? Is there a question to follow that, or you just wanted to see it briefly? Or maybe it was this one. I'll rewind for a couple of seconds. If there's a question, I can answer it. And there, while I'm waiting to see if there's a question with that, how did you find your passion for programming? I will answer that question at the end, just to keep the flow of the presentation going. So if you have questions like that, definitely save them for the end. Keep questions for sort of mid-presentation. Try to have them on either sort of the thing that I'm talking about. All right, so we'll keep moving on. So I was talking about type signatures, or what is known as a function declaration, sort of in C++, Python, or Java. I haven't mentioned those there or here. And in Haskell, this is the first line here, the filter odds : This is, it looks a lot different than what you're used to seeing in C++, Java, and Python. But what this is saying is basically our first argument is a list of integers, and we're going to return you another list of integers. And what's amazing about Haskell is it figures that out for you. If you type this or you type this, it automatically infers what the type signature of your function is, because it has an incredibly powerful inference engine in the language. It's probably one of the most amazing things about Haskell, and why it's in my top 5 favorite programming languages. It's so amazing that this is probably top 5 things I've ever learned about programming languages. There's a website called Hoogle. And if you see here, I've typed into the search bar the type signature list of integers. That's what the brackets mean, a list of integers to a list of integers. So it's taking a list of integers as your argument and returning a list of integers. And it's giving you back a list of functions that match that type signature. So imagine in Python, you could search for a list of functions that, take a list of something and return you a list of something, like reverse, or, take the first 4. You can do that in Haskell. And so a lot of the times when I'm looking for a function that I don't, or an algorithm that I don't know the name of, I just go to Hoogle. I think, oh, I need a function that takes a single integer, a list of integers, and returns me back an integer. And it'll give me all of the functions that exist in standard libraries, or libraries that have been written. You can see the packages that it's searching in. And this is just, it's incredibly amazing. You might not appreciate how cool this is, but if you go and play around with Haskell for a little bit, and then start to realize how powerful the inference engine is, it's remarkable. So yeah, this is like a top 5 thing. I wish every language had something like this. Obviously, it's not possible when your language isn't as strongly typed as Haskell. But yeah, that's everything I want to say about Haskell. Moving on to the next solution. I'm not going to say much about OCaml, although Rohan said I know all the languages. I know some of them much better than others. So Haskell, Clojure, and APL, I definitely know the best. OCaml for me is basically a strict or eager Haskell. So Haskell is lazy by default, whereas to my understanding, OCaml is eager. And they have different philosophies, but they are very much, sort of 2 of the most popular functional languages. And here it looks very similar to the Haskell solution that we had, where we had to explicitly spell out our lambda. So here we're saying we have a function filter odds. It takes a list L. So I think it's idiomatic in OCaml to, instead of using XS, to use L. And then we're making a call once again to a filter function. And here our lambda looks a little bit different, whereas we were using /e, we're using fun x, where x is our argument, and then x mod 2 not equal to 0. OCaml, so there's a question from Bernat that says, OCaml, shouldn't it be greater than, less than for the not equals? I ran this code, so this code definitely works, but there might be multiple operators for not equal. So that could be the case. My guess is that if you're asking the question, then that it is true. But yeah, I'll look that up afterwards. Another question is, can we also write similarly for eliminating even numbers in Haskell, like filter even excess, filter even excess? Yes. So the question is basically, when we looked at the filter odds, is there an equivalent function for filter evens where there's an even predicate? Absolutely. And also too, I'm using the word predicate, which when I was in high school / beginning university, I had no idea what that meant. A predicate is just a function that returns a Boolean. So is even or is odd is a predicate function. And they're used a lot of the times with these algorithms like filter. So moving on to our next language is the Clojure programming language, one of my favorite languages. It was designed by Rich Hickey, and it's probably the most modern of the Lisp languages. Some people really don't like Lisps because they have parentheses everywhere. I think this is kind of an odd thing to say, because someone once pointed out that they don't actually have parentheses everywhere. They have roughly the same number of parentheses as other languages. They're just in a different place. So when we look at Python, you call a function or define a function and start the parameter list with a parentheses at the beginning of your sort of argument list. Whereas here, we just put it at the beginning of the defin for defining a function. But anyways, so this is our function. It's using a kebab case where we use hyphens instead of underscores. Underscores is called snake case. And we have one argument list. And this, very similar to Haskell, is extremely beautiful. They have all the built-ins you need: filter, odd question mark. This is a really nice thing about Clojures and many other Lisps, as they use question marks to annotate basically predicate functions. So whenever you see a question mark, you can know, even regardless of the name of the function, does this function return a Boolean, a true or false? And this basically is everything you need. Similar to the Haskell solution where we showed the more explicit one, this is the one that's using, this actually, very funnily, is not called a lambda. So there are different names for functions without a name. It's most commonly referred to as a lambda in most languages. In Clojure, though, it's referred to as an anonymous function. So just a function without a name. So the syntax for this is using a hash, and then we do our modulus. And note that all of the functions here are prefixed. So even when we're checking equality, the equal sign is the first thing that comes in your set of parentheses. So you're checking, is 1 equal to the modulus of our argument, which we use a shortcut syntax for percentage. So that's just basically the element that we're passing in here. So when we used E previously in other solutions, we use percent here with 2. Someone asking, don't you put a semicolon at the end? No, semicolons actually, they have the meaning of a comment in Clojure. So many languages don't require semicolons, including Python. There are some that do, though, like Rust and C++. So, but yeah, great question. What is the use of the octothorpe or hash here? So this just basically is the syntax to start. So whenever you see a hash with a parentheses, it means you're starting an anonymous function. It's basically a function without a name. So you could spell this, I think, differently by inlining, basically similar when we had the OCaml solution a couple slides back. They do it with a fun. Basically, this is how you, and so in Haskell, if we scroll back a couple slides, you can see that their syntax for this is the parentheses slash. So every language just basically has a syntax to say, how do we start an anon function? OCaml's is paren fun, and Clojure's is octothorpe parentheses. But great question. And there's one thing, so I highlighted Hugel about the Haskell language. Probably my favorite thing about Clojure and why it's in my top 5 favorite languages is that if we take a more complicated example, which we're going to look at, not for every language, but for a few. So instead of just filtering out the odds, what if we wanted to sum the first 2 odds from a list of numbers? So filter out the odd numbers, then take the first 2 and then sum them up. In Clojure, this is what that function might look like. So we read inside out, filter out the odd numbers. So exactly what we started with last time, take the first 2 and then do a plus reduction, which is just another way of saying sum up the numbers. So sum the first 2 odds. A lot of people don't like, including me, this property about lists is you end up one with like all these parentheses. So I said, there's not a ton of parentheses, but in some cases there are. And here you end up reading inside out, which is very unnatural to me. But there's something in Clojure called threading. So this is not, you've heard of multi-threading or parallelism. This is something completely different. Clojure uses threading to refer to this syntax, basically. So they have a thread first, a thread last, and a couple other threading macros. But basically what this does is it takes this inside out where you have to read what's on the inside, then the next layer, then the next layer, and then basically makes it so that you're threading your argument through these functions. So you can just read it linearly. So here, you take your list, you filter out the odds, you take 2, and then you do a plus reduction. And for me, this code is absolutely gorgeous. I wish all languages had like a syntax, because even in Python, you can sometimes end up in situations where you're reading inside to out. And that's not naturally, whether you're reading in English or whether you're reading in traditional Chinese. Sometimes it's left to right, sometimes it's right to left, but it's always linear. It's never inside out in this sort of hierarchical thing. So I always prefer code that looks like this. And threading, and that's the thing, is Clojure has extremely beautiful like support for different types of threading, like I mentioned, but I'm not going to go into too much details. There's a question in the chat. If we want to add the odd number starting from 5 and less than 10 from a queue, what could we write in Clojure? So there's a couple different things you could do, but the easiest would be filter odd, drop 5, take 5, reduce plus. So that's basically, you're filtering out the odd numbers, then you're getting rid of the first 5 and then taking the next 5. But there's a couple different functions that could use it, but that's the first thing that comes to mind. And similarly, you could use threading. So just replace this take 2 with a drop 5, take 5, and then reduce plus. So moving on to our second last, less well-known language. And this is the Wolfram language. I actually don't know a ton about the Wolfram language. I have solved, I think, one programming problem on my YouTube channel. And the tricky thing about this is that it's not an open source language. So I actually solved this using Try It Online, which is a website where you can try a ton of different programming languages, even the most sort of hard to get at. So I'm curious, maybe someone in the question and answer, or even in the chat, how the folks, because it was the #1 or #2 most popular language of choice. I guess maybe most of you have access to it through school. But yeah, this one looks a lot different, but very similar. It calls their filter function select and has odd q as the predicate. And actually, I didn't look up what q means, but I just realized that what it probably indicates is the same thing as the question mark. The q stands for question, which means this is a predicate function returning a true or false. And yeah, so this is all I'm going to say about Wolfram. And last but not least is my favorite programming language of the 5, which is APL. And this has probably the most unique language or unique solution. Or I shouldn't say unique. I'll say different solution compared to the other solutions. So we're going to walk through this step by step because it looks like gibberish if you don't code an APL, which obviously is understandable. So let's focus on these 3 characters first. So we have 2. This is called residue, but it's basically just the analog of modulus, and then omega, which is our argument. So you can replace, in our example, 1, 2, 3, 4 for the omega here. So you end up with 2 residue, aka modulus 1, 2, 3, 4. And so what that basically means is apply 2 modulus across all of these functions. And if you do that, you end up with 1, 0, 1, 0, 1, because every odd number is going to give you 1, every even number is going to give you 0. Hopefully that makes sense. So what we call this in APL is a Boolean mask, because Booleans in APL are represented by 1s and 0s. And once we have this Boolean mask, we can combine it with a function that is, I call filter, but is technically called replicate or compress. And basically what this function does is if you align the Boolean mask with the numbers, and this is going to align basically each 1 and 0 up with a number. And if you highlight the 1s and 1, these are the ones that APL is going to keep. And if we do that, we end up with 1, 3, 1. And so if we go back to our original, this is basically what we end up having. We're building up our Boolean mask and then filtering with that Boolean mask our initial list of numbers, which is omega in both cases here. And now I'm going to show 2 different solutions in APL that are the exact same thing, but this is what makes APL, like there's a bunch of things going on here. The fact that we did 2 modulus, and this is a scalar operation, and it automatically worked over a list of numbers. So that's called rank polymorphism in APL. It's just a fancy word meaning that whether you have a number and a list, or a list and a list, or a number and a matrix, all your operations work for those sets of combinations. But so the second solution is the following. So basically what we've done, if we've taken this 2 modulus omega, and we've put it on the right here, and then we've taken our filter omega and put the omega on the other side of it, and then added this really odd looking sort of selfie emoji. And what this is called is, it's called swap in APL, but it's known as the W combinator. And basically what it does is it rearranges the 2 arguments to your function. So whereas previously we were taking our Boolean mask on the left side of our filter slash and our list of numbers on the right, when we combine this with the W combinator, we're taking our Boolean mask on the right and then our list of numbers on the left. And because we evaluate things right to left, that means that we can get rid of our parentheses, which isn't a big deal, but code golfing is a thing in APL where you want to get your solution as short as possible. And the last solution that I'm going to show, and I don't expect you to understand this, but this is basically the point-free solution where we get rid of our omega and our braces, and all we have now is an expression that is not mentioning our arguments anywhere. There's a question in the chat from Ankit that says, if we want to print a table of any number that after multiplying gives an odd, how can we write in APL? If we want to print a table of any number that after multiplying gives an odd, how can we write that in APL? I'm not sure I totally understand that question. Maybe try rephrasing it, and then I might come back to it at the end when we've got a ton of time for questions. So yeah, these are the 3 solutions. So there's another question that says, I've never tried APL, but wondering if it's not a bit of a pain to type all the special characters like omega. I get this question a lot on Twitter, but the truth of the matter is it's not hard at all. There are basically keyboard shortcuts. So on mine, if you go back tick and then just type a letter, you'll get a symbol, which you have to memorize. But I mean, I've never even actively tried to memorize them. It just happens from typing them. And there are keyboard apps and I don't know if it's 2 billion people that speak Mandarin Chinese in the world, and they all manage to type in pinyin. So, I mean, it is a little bit of a, it's more difficult than writing in ASCII English characters or whatever your language of choice is. But it's definitely not a super big challenge. And before we move on to sort of the next part of this talk, I also want to show sort of BQM, which is my favorite language, and the translations into BQM. And it basically is identical for the first couple. So if you look here, the only difference between BQN and APL is that BQN uses a overstruck X instead of an omega. Everything else is identical. For the next solution, once again, basically identical. The only difference is, once again, we're using an overstruck X or double struck X. And instead of this little tilde with 2 eyes, we have a superscript tilde up in the top hand corner. Where it gets interesting, though, is that I didn't really explain this point-free solution, and that's because this right tack and this little sort of surprise-looking guy here, those are only necessary because of sort of ambiguity in the APL language that could be better. So the translation of this in APL is actually much nicer. This right tack and sort of 2 dots and the surprise guy have disappeared, and we're 2 characters less on this side. So basically, you can almost see the resemblance now between this third BQN solution and the first one, where instead of braces and our overstruck X, we just basically have these 2 functions that are for identity, aka our argument. And last but not least is the shortest of all in BQN, which is the point-free solution conversion of the second solution. But that's all I'm going to say. Hopefully I've intrigued you. This should blow your mind in terms of like how short it is and how much you can do. But if you didn't understand this, don't be scared of learning the languages. when I started learning them, I basically just learned plus slash to sum a list of numbers and got hooked that way. But just know that similar to Haskell and other languages, this will completely change the way that you think about writing programs. And Rohan mentions in the chat that he personally likes using the swap operator. But I'm wondering which of these solutions you think is most usable / readable, especially compared to point free. I think that so there's an argument between the 2 point free solutions and the 2 sort of defund solutions, which are the ones that use the braces. I would say that both of these top 2 are more readable than the point free ones, but that's just because most people don't take the time to learn point free notation. Between these 2, though, I think more people can read the first one because it requires knowing less characters. Here you have to know, I mean, technically that's not true. You need to know the parentheses, but it's almost a default that even before people come to programming, people understand what parentheses are for. That being said, I think 1 character difference is not a huge deal. I would probably write it the second solution, but if people argued that the first one was more readable, I wouldn't disagree. I'd say they're both as readable, and if you want to write one way, I think it's more in the cases where the use of a combinator enables you to eliminate not the second use of an X, but the second use of a variable that's called, life points, or life score, which is a 10 character variable. If X was life score and it was like 10 characters, not having to spell that a second time would basically shorten your solution by a factor of 50%, which would be a huge deal. All right, so coming back to our popular versus less well-known languages, we're now going to look at Python, C++, and Java once again, and see how we can sort of write solutions that are closer to what we saw in our less well-known languages. So this is what we started with in Python, but we can also do this, which is kind of the functional solution in Python. We're making use of a lambda, which uses the explicit lambda keyword, and we're making use of a function called filter, which they also have as a built-in in Python. On top of this, we can also make use of a list comprehension, which I mentioned earlier in Haskell. So here we're basically saying for every element in our list, if that element modulus 2 is equal to 1, which converts to a Boolean, keep that element. So we can basically do our filtering and have a sort of lambda implicitly here in our if expression of our list comprehension and get the exact same solution. And I think that it's most idiomatic to write the last solution here. If you see this in code, you should immediately think, oh, I'm building up a list by adding things to it only using an if conditional. I can do this in a list comprehension. And you'll probably see this in code review in the future if you're working for a company or on an open source project, and you see this kind of loop that can be written in a single line in a list comprehension. For our C++ solution, there's a question, is this similar like if statement to check? Correct, yeah, this is basically just a different way of writing the if statement on a single line. They have the list comprehension syntax so that you can write basically a built-in if statement in your list comprehension. Correct, yeah. So for our C++ solution, this was what we initially started with, but we can use something from C++ 20. So that's one of the most modern C++ versions. We have something called ranges, which are highly inspired by functional programming languages like Haskell. So now we have this lazy filter view that, given a lambda, will basically filter out elements. And now we have a lambda. The syntax is very ugly compared to other languages, but once again, we're doing our modulus 2 operation. And this is the exact same thing. And if we take this lambda out, name it odd, you can almost see that this kind of looks like Haskell code. It's a little bit more noisy. It's definitely not as beautiful, but it's much nicer in my opinion. There's a question. So the lambda, you use lambdas to help writing everything in one line. You use lambda, yes and no. The purpose of a lambda isn't to write things in one line. The purpose of a lambda is so that you can use generic functions like filter, where you can customize the behavior of that function by encapsulating a piece of logic. So here we're filtering in odd numbers, but you could filter in, letter or names that start with the letter A by, giving a list of strings and then creating a predicate that checks, is the first letter of your string equal to A? The behavior here is generic, but you can customize your generic functions to have sort of different behaviors by encapsulating these little pieces of programming here. Rohan asks, is there a performance trade-off compared to C++ solution in the previous one? If anything, the filter one should be more performant. So basically, it's a zero cost abstraction, but this is a lazy view. So in the next slide, I'm sort of showing another version of the sum. So actually, this should have been changed to sum first two odds. But here we're doing a take two. I haven't shown the adding the numbers up because you can't do that yet in C++ 20. But here, because our model is lazy, if you had a list of 1 million numbers and you wanted to filter all the odd ones and then take two, here, you're only going to filter up until you end up taking two of them. So if your first two numbers in a list of 1 million numbers are odd, you're basically just going to take the first two and you're never going to look at the rest of the 999,000, et cetera numbers. In the chat, it says, if we want to change any line, we usually use endl after cout in C++. Yeah, that's for IO streams and outputting, which we're not really doing right here. So, but that's a good point. And the last thing I want to point out about the C++ is, like, quote unquote, trying to make this look like Haskell. If we do this using namespace stood views so that we don't need to put stood : views : in front of all of our views, and then separate this a bit, you can see that, like, it looks different. But this is starting to look like our functional solutions where we were able, in Clojure, to pipe things together when we had our sort of threading macro, filter, take, and then add things up. And last but not least, of the three solutions that we've seen before from our more popular languages, here's our Java. And in Java 8, they added something called streams, which I'm not super familiar with, but I know they exist. And so we can do something, once again, now this is looking very similar to our functional solutions. So we change our list into a stream, and then we can call on stream a bunch of functions and can concatenate them together. So we filter. This is the syntax for a lambda in Java. And then once we have that, we can collect this up into a list. And so this does the exact same thing as this code. In my opinion, this is easier to read, and it's also nicer to write. And similar to what we just looked at for the C++ solution, we call the take something different. We call it limit to, but then we can also do the same thing where we're summing our first two odds by basically doing a filter, a take, or in this case, it's called a limit, and then a reduction. And there's another question in the chat that says, sorry, could you repeat what it means to take two there? So yeah, I can do that and talk about limits. So basically, say we have a list of 5 numbers, 1, 2, 3, 4, 5. We filter the odd ones. You're left with 1, 3, 5. And then when you do a take two or a limit to, you take the first two that show up in your list. So in our case, when you have 1, 3, 5, so 3 odds, you take the first 2 of those, which is 1 and 3, which means you don't care about 5. And if you had 100 odds, you wouldn't care about the last 98. You only care about the first 2. And then so with 1 and 3, when you add them up, you'd end up with a result of 4. And yeah, to repeat what a lambda is, so I've mentioned this, and we'll talk about it at the very end, which we're getting close to, is a lambda is just a way of basically writing a function without naming it, which has special syntax in every language. So in Java, you write a function like this. You've got your return type, integer, your name of your function, your list of arguments. In Java, a lambda is what's inside the parentheses here. Here, you have no function name anywhere. You have no return type because that's inferred by the compiler. And your argument list is E here. And the type of the argument is also inferred. So basically, this is a function, an anonymous function or a lambda that takes a single argument E and then performs this operation on these arguments. Or sorry, yeah, on each of the elements that get passed to filter. So in the case of 1, 2, 3, 4, 5, your first number is 1. So E is equal to 1. 1 modulus 2 is going to give you back 1. And 1 equal to 1 is going to be true. So you're going to keep 1, if that makes sense. No problem. So last but not least, I'm going to go a little bit quicker here because I want to leave time for questions and we've only got 11 minutes left. The two solutions we haven't looked at, Rust and Kotlin. Why did I leave these for last? Well, these are outside the top 10, but as I showed in the language website, they've been gaining in popularity like crazy over the last 10 years. So this is the Rust solution. Not going to spend a ton of time of it, but once again, filter, checking modulus with 2, equality to 1, and then collecting. And if we, once again, add the sort of take 2 and sum, where we're summing the first 2 odd numbers, take 2, sum. Looks very similar to our functional solutions. If we go over to Kotlin, look how much changed there. So Rust is a low-level programming language where you have to do manual memory management. It's for systems programming. Kotlin is a language that is the evolution of Java that runs on the JVM. They work in completely different spaces, and these solutions are almost identical. Other than the into iter and the functions signature, they basically look the same. And the point here is that these are modern, popular languages. Rust is kind of the evolution of C++. It's a more modern C++ that's gaining a lot of popularity. Kotlin is a more modern Java. And so these modern languages are borrowing things from the less well-known languages like Haskell, Clojure, etc. So the point being is that even if at the end of the day, you're going to end up writing in a language like Python or C++ or Java, you should be learning these languages on the right because you end up stealing ideas from these. And lambdas, when they showed up in C++, everyone thought they were so cool, but lambdas have been around for decades. They've been around since the 1950s in languages like Lisp. And C++ programmers think they're really cool, but if they had been studying Lisp and APL and these other languages, they would already have seen these ideas. And last but not least, and I'll burn through this. So I've been talking about lambdas. This is basically just a summary of all of the different lambdas in each of the 10 languages that we looked at, sort of from shortest to longest. As you can see, APL is at the top, not surprisingly, and C++ is at the bottom. There's 2 of these that are a little bit different. I mentioned this at one point, and that's these 2 because they're not comparing equality to 1. So here, if we want to be fair, even though you don't need to, you're adding the equality with 1 so that the implicit conversion is not taking place. If you want to read more about lambdas and different types of lambda syntaxes, there's a blog that was written by Barry Revzin called Lambda, 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 where he looks at like 20 different languages and the lambda syntax and how they show up in those languages. And yeah, I will end my talk there, say thank you, and open up the floor to any and all questions that folks have.
Yeah, thank you so much, Connor. That was an amazing talk. I guess I can start off with a question, and then from there on, anybody can just sort of unmute and ask their question. But I know you had mentioned that like these functional sort of programming idioms are making their way more and more into the more popular languages. And so as I've also been trying to learn C++ a little bit lately, since it's sort of one of the popular programming languages I don't know. And I'm wondering if you think that a lot of companies which have like super large code bases based on C++, if they're actually sort of thinking about trying to rewrite and maybe remodernize these code bases using these more functional programming idioms, or is it like not at that level yet to which it's infiltrated these languages?
No, so the short answer to your question is yes. There are tons of companies that are upgrading from C++ 11, which is I think what most companies are on, to C++ 17, 20, and are making use of all these new functional features. Like lambdas is only one of them, but there's a ton of other things that have been added to C++ that are making them more functional. That being said, probably most of you aren't following all the C++ exciting news, but basically Google over the summer announced a new programming language called Carbon, which is basically supposed to be a successor to C++, kind of the same way that Kotlin is the new Java. They're hoping that Carbon will be the new C++. And there is also been a couple other proposals of sort of languages. You know, Rust is about 10 years old at this point. But the point is that C++ is a great language to get a job in. It's very well paying, and there's a ton of job opportunities out there. If I was in high school though, or beginning of university, I probably wouldn't learn C++. I would probably go and learn Rust, because there are statements being made by like international governments, including the United States, that are saying that like unsafe languages that don't have memory safety built in shouldn't be used anymore. So I think Rust is like a safer bet. That being said, like you can't go wrong with C++. It's going to be around for decades to come. Similar with Python. Like if anyone tells you, oh, you shouldn't learn Python, Python's like the most popular language in the world. You're like it might be fun to learn languages like Haskell and stuff, but yeah. So yeah, short answer is yes. Long answer is learn languages like Rust because I think they're the future. So questions, do you want me to read the questions? Yeah, I'll read the questions. So do you think, from Ankit, do you think learning these less famous languages will add value in my resume to land at giant companies like Google and Microsoft? Yes and no. I mean, definitely yes. So the no part is that Google is famous for having something called the silver languages, which are like Python, Java, C++, and there's like 4 others. You can Google it online. And they are the languages that they predominantly, I think Go has to be on the list now because they invented that language, that they predominantly write in. But like for me personally, if I saw that someone coming out of university had experience in OCaml and Haskell and APL, that would indicate to me that this is someone that's truly interested in learning and passionate about what they're doing. That doesn't mean that someone that just has Python and Java and C++ on their resume isn't passionate, but it's a clear indicator that if someone has taken the time to go and learn languages that are sort of not super popular, that they're very curious and interested to learn things. So I think it definitely helps. But in general, just having projects that you put on your GitHub and having done projects in any language is something that really helps. Another question from Vibehav, I think. I apologize if I mispronounced that.
Yeah.
Knowing many languages helps you get a position, something called the main IT.
Actually, I'm not sure about it, but I heard one of the teachers telling me that like if I learn many languages, there's some position in the IT where you can like, it's like a hard role when you get a lot of money getting the job.
Oh, so I think the question is, does knowing many languages help you get a position in the main IT companies?
Yeah.
I think it can help, but I would, if you're trying to optimize getting a job, I would know one language really well versus knowing every language very poorly. So if you're going to study languages, make sure that you know in depth at least one language so that when you go into an interview and you need to do anything, you're able to do it. I wouldn't spend, like 1 week learning every language so that you know 40 languages. So it's sort of a balance, but I think it's definitely good to know more than one, but definitely you want to be strong in at least one of the languages so that when you're doing coding exercises in companies that you'll be able to answer them well. Next question from, let's put this on the big screen so I can read them better. Louisa, what do you think are the best languages for someone to learn? That is a hard question to answer because you have to qualify it for what? If it's, I'll answer the question being, what are the best languages to learn in order to expand the way you solve problems? And for me, that was Haskell was the first one, and then APL was the second one. And then after that, I would put Smalltalk. So languages like Pharo. Yeah, if you're ever thinking of adding languages to your repertoire for this contest and conference, I would say Smalltalk should probably be the next one because that's an object-oriented language that is super interesting to learn. Any recommendations for learning data structures and algorithms using C++? I would just Google, Google on YouTube. There are a ton of great YouTube channels that cover C++ stuff. And also if you Google, there's a website called Hacking CPP that has a ton of really, really good cheat sheets for data structures and algorithms. That is a great starting point, and they have a ton of links. A question from Ritesh: as someone who is starting university, which would include a course on data structures and algorithms, would it be a good idea to learn C++, Java for the purpose of trying to achieve the same in more modern languages? I think both. I think C++ personally is a better language to learn data structures in because and algorithms because it has better support for generic programming. But I mean, honestly, any language like Java, Python, C++, Rust, Swift, Kotlin, I think are good languages. Like it's the same concepts just being implemented with a different syntax, really. So yeah, don't worry too much about the language. And Keat asks, I am currently learning data structures from C language. Will that be helpful? Yeah, like I just said, I think a lot of people over-index on the language that's being used in a certain course. But really, I think once you learn enough languages, it's all the same ideas, just with a different syntax at the end of the day. Also, Rehan, feel free to cut me off whenever you need to hop to the next section. Hamish asks, thanks for the talk, really inspiring. Wondering if you have any recommended resources for keeping up to date with the exciting new features in C++ 17/20 that aren't a million pages. I listened to, CPP Cast used to be a really good podcast, which ended for keeping up with C++. There's another podcast now called C++ Club. It's not as exciting because it's only one person, but they basically give little 20-minute updates on the most recent papers that are going through the standard process. And there's also a really good YouTube channel called C++ Weekly by Jason Turner. He has basically weekly videos where he talks about everything in the modern languages. So that's also a really good resource. Question from Lucas. What would you say is the language most searched for in job interviews? Depends on your industry, but I'd probably say Python or JavaScript, just because they're the two most popular languages in the world. Yeah, that'd be my guess. And they also usually show up at the top of most programming language rankings. Pepe asks, as a person who is experienced in many languages, do you think that creating a universal syntax for every language would be easier for programmers, or do you think that the different syntaxes are custom made for the languages? I think it is different by necessity, not because people want it to be. So the reason why C++'s syntax is so different is that it's a language that's been around for 40 years, and we can't break backwards compatibility. So when we're going to add a new feature, it can't infringe on any of the other C++ features that currently exist. Whereas a language like, and similar with Java, when they added lambdas, they have to make sure that they work in the ecosystem that Java currently has, and they've been around since the 90s. Whereas a language, and similar even with Python had been around since the early 90s as well. So languages like, Rust and Kotlin, they have a lot more freedom to create whatever syntax they want. And that being said, even across languages, like there's going to be differences because different languages are used for different things, right? There's languages that operate at a very high level for, front-end web design. And then there's languages that are doing, kernel operating system management at the low level. So there's always going to be, different questions. And I think Rohan said, let's end the Q&A with Pepe's questions. But thank you everyone for all the awesome questions, and good luck with the hackathon, and hope everyone does awesome.
I think there was just one more quick question if you have the time.
Sure, yeah.
It was actually I think Ankit asked what recommended free resources for learning APL. I mean, obviously your YouTube channel is one of those, but
for Haskell and APL, so it depends on. So Haskell, there's a ton of great resources. There's a free book online called Learn You a Haskell, it's an online book for free. Some people say that it doesn't go super in depth, so you're not going to end up with a really in-depth understanding, but it's a great starting point. And there's, I think, 2 or 3 different Haskell podcasts and a couple different Haskell YouTube channels. For APL, I would recommend a couple different YouTube channels. If you basically Google APL Wiki, and then in there's a ton of APL resources with a few different people that have YouTube channels that focus on APL. And then there's a book called Mastering Dialogue in APL that I think came out in 2012, but they're in the midst of polishing off a revised version for 2022 that should be out, I think, in the next couple months. That would be my starting point for those questions.
Okay, I think that's all the questions we have. So just thank you again, Connor, for giving us some of your time. I'm sure everyone agrees with me, but I thought this talk was really cool. And especially for the people who are in a single language track, I think it's cool to see how similar these ideas are across all languages, and how you demonstrated knowing one is super helpful to learning the others. So I just want to reiterate, thank you so much. And we really appreciate your time.
Yeah, no, it was a blast being here. And once, like I said before, good luck to everyone in the hackathon, and hopefully you all end up learning a ton. All right. Bye, everyone.
Yep. Thank you.
Right.